Alright, this video is going to go through the answers to question 3. This is about the difference in boiling points between alcohols and aldehydes, and you're given some information in the table. So the first question, draw the full displayed structural of pentanol. Let's start with the pent. That means a carbon chain that's 5 carbons long. There we go. And then the suffix anal, meaning that there's an aldehyde functional group, C double bond OH on a terminal carbon, and then we just put in the hydrogens on each of those carbons. So that's the full displayed structure of pentanol. 3.2, name the aldehyde that's a liquid on a warm summer's day in Cape Town. So a warm summer's day, temperature would be between 25 and 30 degrees. If we then look at the aldehydes, that's the side of the table we're looking at. Methanol boils at minus 19 degrees, and so if the temperature is 25 degrees, then it would have boiled already, which means it's a gas. Ethanol boils at 20 degrees, so it also will be a gas. Propanol only boils at 48 degrees. Now it's not going to get up to 48 on a warm summer's day, and so that wouldn't have boiled yet, so that will still be a liquid. In fact, all the others will be liquids, so any one of those three would have been the correct answer: propanol or butanol or pentanol. Alright, 3.3, describe the trend in the boiling point of the alcohols. So we're now looking at this part of the table, and if we have a look at the alcohols, methanol, ethanol, propanol, butanol, pentanol, you can see that as we go down the table, the carbon chain's getting longer: methanol 1 carbon, ethanol 2 carbons, etc. And if we then consider the boiling point, we can see that as the chain gets longer, the boiling point increases. So methanol from 65 up to pentanol at 138. And so the trend is that as the length of the carbon chain increases, then the boiling point also increases. So as the length of the carbon chain increases, the boiling point increases. Now just note that the way we've answered this is to specify the change in the independent variable, that's the length of the carbon chain, and then state how that impacts the dependent variable, which is the boiling point. That's a useful way to think about answering these kind of questions. Alright, 3.4, explain the trend. To do that, we need to talk about intermolecular forces, and so we would state that the longer the chain, the greater the effective surface area, and hence the van der Waals forces between the molecules are stronger, and hence more energy is required to overcome those forces. So that's the explanation. 3.5, notice in this question it asks you to state and explain the relationship between boiling points of alcohols and aldehydes of similar molecular mass. So if we look at methanol and methanol, notice that the methanol's boiling point, the alcohol, is 65, whereas methanol, the aldehyde, is much lower at minus 19. If we choose two others, propanol is at 97, and propanol is at 48. So in each case, the aldehyde has a lower boiling point than the alcohol. Now, it requires us to do two things: firstly, to state the relationship, and then secondly, to explain it. So let's start by stating the relationship. Alcohols of a similar molar mass to aldehydes clearly have a higher boiling point. So that's the statement of the relationship. The explanation is that the alcohols have hydrogen bonds, so the hydrogen bonds in the alcohols are stronger than the van der Waals forces in the aldehydes. 3.6 then asks you to predict how the boiling point of ethanoic acid would compare to ethanol. So there are two molecules of ethanol, and you'll remember that the oxygen is slightly negative, the hydrogen slightly positive, and so we get an interaction between those two molecules, and that's what we know as a hydrogen bond. In a carboxylic acid, in this case ethanoic acid, as two molecules come together, you'll notice that there are two sites where hydrogen bonds can occur. So at the top of the molecule we can have a hydrogen bond, and towards the bottom we can have a second hydrogen bond. And so the difference in boiling point relates to a greater number of hydrogen bonds in the carboxylic acid. And so our explanation would be that, well, our statement would be that ethanoic acid would have a higher boiling point, as each molecule has two sites where hydrogen bonds can form. And if you look at the table, you'll see that ethanol has a boiling point of 78 degrees, and if we look up ethanoic acid's boiling point, it turns out to be 118 degrees.